All right, here we are, boys and girls. It's me, and we're back. It's OG Steve Stroh, and we're back for another chapter on programming in BASIC with the Tandy Color Computer, and we are continuing on hashtag commitment CoCo to finish this chapter this month. This will be the third chapter I've released in 1 week. This is now chapter 29. This chapter is called Analyzing, and of course, I'm going to pronounce it that way because I'm immature. But, and I'm going to tell you up front, number one, my head has already exploded by going through this. It's not that complicated, but this chapter is just not easy on my brain. The examples they give us illustrate the concept, but I'm really having a hard time understanding the purpose and application of how often I would use this in any program I wrote. And again, I mostly made entertainment content. So the way we're going to go through this, it's not going to help any game in any way I can imagine, but I'm hoping that I can figure out some type of better example down the road. In the meantime, what I've done is just try to make the book's examples a little bit more human-friendly and less monotonous to go through, because it's doing a bunch of voting crap and districts and candidates, and it just, the way they had us go through it, it wasn't super human friendly, and I even found an omission in the book that I corrected. I was actually able to see it as I was reading the code, so I'm getting smarter in my old age. So the chapter is called Analyzing. And one of the things they're warning you about here is, in order to clear this much memory to do all these things, they're saying you have to have more than 4K of RAM. So this probably was part of the original Color Basic manual. There was a time where Color Basic and Extended Basic were two different manuals, and so this probably lived in that manual. And if you had bought a stock CoCo 1 with 4K of memory, you might not have been able to do all of this. So in any case here, if you've got more than 4K, which hopefully at this point you do, there's an easy way to analyze information by giving each item more than one subscript. And you can see it through different dimensions. So here it says, take that voting program we did in chapter 19. Here's the information. We're only using the first 3 districts to make the program simple. So we got 3 districts, not going up to District 9. We've got 2 candidates, and each of these candidates received a certain number of polls. And from the look of it here, I don't know who candidate 2 is, but I'm thinking the word landslide applies to candidate 2 with these numbers, but that's neither here nor there. So in chapter 19, you stored the above items, groups of votes, in 2 different one-dimensional arrays. We had array A for one set of data, and then array B for another set of data. In this chapter, you'll store them in an easy to manage 2-dimensional array that we're going to call array V for votes. And it says the following programs puts the items in array V. But then what happens is, after you read in these numbers, it then wants you to ask a series of questions to give you back one number at a time. So I found it to be too highly interactive and yielding a very small amount of information to not benefit from the amount of user input required to do this. And so what I basically did, and let me switch over to the big version of the CoCo here, is I went ahead and on our first program, which we will call 29-1. You gotta spell load right, I guess. So when we load up program 29-1, which is similar to what they have in the book, but what we're going to see here is that we've got the same sets of data, 143, 678. So this is candidate 1, district 1, candidate 2. I got to move the mouse over here where you can see where I'm moving my mouse. So candidate 1, district 1, candidate 2, district 1, candidate 1, district 2, candidate 2, district 2, candidate 1, district 3, candidate 1, candidate 2, district 3. So you've got 2 sets of numbers repeated 3 times for the 3 districts, and it's all strung out in one long data statement. So the way we read this in is we first go through our district. So we're going to say for district equals 1 to 3. And then we're going to say now for candidates equals 1 to 2, because there's two candidates in each one. So what I do is I read in the vote for the district, and the candidate. So right now, D is 1 and C is 1. So I'm going to be reading in vote for District 1, Candidate 1. I'm going to print out the district, which right now will be 1, and then I'm going to print the vote for district and candidate, which would be the actual number I read in. So for District 1, Candidate 1, I am going to print out that actual number, and then I'm going to do that twice because there's 2 candidates that I have to read for each district. So the C loop will complete inside the D loop. So this is what's known as a nested loop. So we're going to do the D loop 3 times, and inside that we're going to do the 3 loop 2 times. So you're going to get 2 candidates for each district, and it's going to read in the numbers, and then I'm just going to display them on the screen. And what we should see that this is going to match the table from the book, because we're taking all of these numbers here, which are now just written across the screen from linear left to right, and we're basically reading them into 2 columns that go down 3 rows. Right? Is that the right word for it? I think so. 2 columns by 3 rows. So that we're reading in all this number. So reading in 2, reading in 2, reading in 2. And so I tried to visualize that rather than having it ask you arbitrary questions. Well, which candidate do you want to know? Which district do you want to know? And spitting out one number. I tried to print it out in that kind of table format. And then I even got fancy and showed you what these variables look like. So let's get jiggy with it, and let's go ahead and run it here, and I'll show you what Willis is talking about. So I'm displaying the information 2 different ways. The first way will hopefully resemble what's in the book. So if we switch back to the book real quick. In the book, we should see the numbers 143, 678, 215, 514, 125, 430. These are just random stupid numbers they picked up to assume these candidates got these many votes. So for District 1, Candidate 1 got 143. You follow that? When I go back to what the CoCo says, so District 1, Candidate 1 got 143. The exact same thing that's in the book, right? But the way the program was having you type it in, rather than just displaying that information for you in these easy to read columns, it wanted to ask you a bunch of questions and just give you one of these 6 numbers. So it would say what district, what candidate, and if you put in District 1, Candidate 1, it would spit out 143, and so on and so forth. And I found that to be a lot of rigmarole going around in circles just to see one number. I know they're trying to illustrate the concept that things are stored in arrays. The second thing I tried to do was to show it to you more a little bit visually on how BASIC looks at this. So this is the array. So the array is V, and it's a 2-dimensional array. So V1, 1 is votes for District 1, Candidate 1. V1, 2 is votes for District 1, Candidate 2. And you can see here that votes 1, 1. Just imagine these are your 2 cells in your array. Imagine this is a grid. So we got 1, 2. So we got 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2. This is how this kind of thing is going here. So you can kind of see here that these are what these variables look like. And if you weren't sure about that, if you just wanted to proof any of that out, I could say, all right, prove it to me, hotshot. Print out V 1, 1, and that should be the same number of 143, and it is. And if I go to the opposite corner and I say print out votes for Candidate 2, which is District 3, Candidate 2, that should give me the 430, right? So this is how the information is actually stored in your computer's memory. The V variable is a 2-dimensional variable. So it's got 3 subsets for districts, and within those 3 subsets, it's actually got 2 separate variables for Candidate 1 and Candidate 2. It's a very elaborate way to store information, and I'm sure there is some really good uses and excuses for doing this. But just trying to follow the book and type this stuff in and keep my brain soaked onto the page of this was very difficult. Literally, my head hurts from all of this. But what I am hoping on the first example in the book is that my output helps visualize these numbers, how they are read into memory and stored into these different arrays, and hopefully it visualizes it a little bit better than just asking you a bunch of random questions to show you one number that you would then have to cross-reference back to the page of the book to see if it made any sense. So I'm trying to distill the information. So that is the first one that we did. And now it's going to go through here. And now again, it's showing you again here in the book what it looks like, right? So V1 comma 1 is 143, V1 comma 2 is 678, which matches this crap up here, right? So I just tried to visualize that for you with the actual program. Now, the next thing it wants us to do is, this one got to be really long and it was like a lot of typing. And I was like, you know what, screw that. I kind of don't want to do that. I think my program actually fixed all this anyways. So then we got into the third dimension, but I don't know. Let me look at my stupid programs. I don't remember what all my programs did. I've been working on this crap for, it feels like 2 hours just getting these programs done. So that was 29-1. Let's load in 29-2. I don't even remember which one was which. 29 and I just did this today. It's not like I did this 9 months ago. This one, okay. Yeah, this one, this one, there was a line that was missing from the book that I found out. So the next program here, I don't know, that might not be it. I think this here was still getting into stuff. I don't remember. Or did we start getting into three-dimensional arrays? No, this is still the two-dimensional array. I told you, I'm lost. My head's exploding. It then had us, okay, so again, this was going to print out the stuff in a table. I just made that much more concise. So, but to give you an idea of what the original program was asking us to do, again, I'm telling you, I'm losing my freaking mind here, right? So, oh, this is when we have the different interest groups. Never mind. So now we're getting into the third dimension. So we're going to go back here. So when we get into third dimension, I created a simplified version. I created two different simplified versions of a three-dimensional array. In this one, I had an even harder time wrapping my brain around of what I would use this for outside of this completely fabricated example they created for us here with interest groups, districts, and candidates. So now we've got data inside of data. It's just like my head's exploding, right? So they want to dim your votes now by 3 for your groups, by 3 for your districts, and by 2 for your thing. And now we're reading in a whole new series of numbers. So I got 143 and 678 from this group. And then I've got 215 and 514 from that group, and 125 and 430 from that group. So this whole line here in line 10 is representing all of this data for candidates 1 and 2 from districts 1 and 3 inside group 1. You follow me? This is now group 2. Candidates 1 and 2 for district 1, candidates 1 and 2 for district 2, candidates 1 and 2 for district 3. There's that data, and so on and so forth. So it's breaking all that stuff down into data statements. It's then having me create 3 sets of nested loops, and this is where we missed a line here. So there really should be a line 100 that said next G, because we've got a loop inside a loop inside a loop. So we first start by counting through our groups, and we go through a loop of 3, and then we then do our districts, loop of 3, and then inside each district, candidates, loop of 2. So it's nested looping that goes inside like 3 layers. But in the actual book, they forgot a line to say next G. I was actually able to detect that as I was even reading through this. I'm like, you idiots. And then, of course, it starts to ask you, now that it reads in all this arbitrary data, it wants to ask you a series of 3 different questions to spit out one of these sets of numbers, which I don't find to be that useful. But I simplified it just a little bit, I think. And so here's my first attempt at trying to create a simpler version of this complex flustercluck of a program right now. So we're going to run it. And so now it's basically saying, well, what's your interest group? All right, well, I'll play your silly game. Let's look at the book here for just a second, and let's just go straight in the middle. So we're going to say interest group 2, district 2, candidate 2. That number should be 157. So just remember that, right? So interest group 2, district 2, candidate 2, 222. The answer should be 157. You following me? I hope so, because I'm not, right? So what's your interest? 2. Let me click on the stupid CoCo. Now I got 3 screens and I'm losing track of my freaking screens right now. 2, 2, 2. So candidate 2 and group 2 got 157 votes. So did I say the answer was 157? I think I did, and I think I might have screwed up in how I presented the information, but yeah, the answer was 157. So this whole line of questioning to ask you 3 different questions to only spit out one number, I found wasn't the best way to visualize the 3 dimensions of data that you got. I'd prefer to see a printout and on screen that makes it easier to read. And then they gave us a really, really long, complicated one to do that. And just looking at it, I'm like, you know what? Screw that. I don't want to type that crap in. So then what I did is I came up with my own version of that, which simplifies it a little bit. It's the same, but I'll be modest and say better. So let's do 29-3. Same sets of data, but I provided a slightly better way of presenting it to you. But you still have the same sets of data. So when I list through 90, you're going to see the same data is in there. I'm reading in the 3 groups, 3 districts, and the 2 candidates per. But then instead of asking you a bunch of random questions, I just go ahead and give it to you. That's what she said, right? So here's the results for group 1. So this is my 4G equals 1 to 3. Right now, G is on 1 for group 1. And then I do for D for district equals 1 to 3. And then for C for candidate equals 1 to 2. And I'm spitting out all that information. And I try to format it and head it up to make it look a little bit more presentable. And if we were to cross-reference this back again with the book, we will see that District 1, we got 143, 678, 215, 514, 125, 430. That's just the numbers they gave us to play with. And so now what I'm showing is I'm running through the same kind of process, but rather than asking you a bunch of questions to give you one of these 6 numbers, I'm trying to very pleasantly display the whole thing to show you this is my data. And it's a 3-dimensional array. And my head's exploding trying to think of how many times this is really useful. Again, I never wrote applications or utilities or anything practical, but I'm really, really struggling right now to think of I'm having a hard time thinking about what I'm going to do with a 2-dimensional array. 3-dimensional array that's just numeric. And it would be nice if we could be a hybrid of text and numbers to read into things, because then I could think of some examples like reading in high scores and reading in the name and the score for a 2-dimensional array as a text string and a number string as one thing might be kind of cool, but I don't think you can mix and match. So it has, because V by itself is a numeric variable, so all the subsets you create all have to be numbers too. So really struggling with how this really benefits anyone, but hopefully somebody who's watching this will think of a reason. Please leave me a comment and let me know. So for group 1, here's the numbers. For group 2, here's the numbers again. This does match what's in the book. And then for group 3, here's the numbers again. And that matches, and then we're done. So I just tried to take the examples and make them, I don't know, a little bit prettier. And I feel really bad because I'm not trying to phone this in. I'm not trying to rush through this. I know I mentioned I want to complete this because it's been a monkey on my back, and I do, but I don't want to cut corners, and I don't want to compromise the quality or the intent or the integrity of what I'm trying to do here. But in this particular chapter, it's just really hurting my head. So I'm hoping that I'm explaining it well. I mean, I'm literally just doing what's in the book and hopefully making it pop up on the screen slightly better. But that was example number 3. And then I created one more that has nothing really to do with the 2-dimensional and 3-dimensional analyzing, but I'm more of a visual person and I like pretty things and I like colors. So I just made this bonus program as my kind of makeup gift for how painful this chapter has been and this topic has been. So I made a program that's going to end up putting pretty colors on the screen. And the entire program kind of fits on here, only a little bit scrolled off. But so first I'm going to print on the screen the colors of the rainbow, or at least the colors of the CoCo. Now, the way I have my data stored in here, this unfortunately I can't read this as a 2-dimensional or 3-dimensional array because they have different purposes. So I'm reading in 3 different 1-dimensional arrays, but it's related. It's similar. I'm reading things in and then outputting what I read, but this one's going to look prettier. So what I ended up doing was I read in the number. For example, when we do our CLS statements and our sets and our P sets or sets and resets, 0 is black. And so that's the number, it's the name, and then there's an ASCII code that will actually generate a color block on the screen. I don't want to get too far ahead of the program, but let's just say I had to look that up in where's my frickin' thing right here. So this is a handy reference if you still have one of these, but this little reference here shows you how to calculate the formula to figure out your different blocks, right? So on your kind of pseudo text mode, I'm using character block 15 to make it a solid block, and then I'm adding color. And there's a whole formula to figure out what the ASCII code is to print that on screen, and I actually used an Excel. I'll show you my Excel spreadsheet that I used to do this with. But yeah, so here's the Excel spreadsheet that I used to figure out their stinking formula that was basically in the book. And the formula is wrong for black for whatever reason, but it's good for all your colors. So black actually ended up being 128. So everything else, these numbers worked out, and I'm just following the formula that was in the book. But I'm not that good in math, so I used a spreadsheet. So on that note, I'm going to explain to you what my program does, and then I'm going to show you my program so I can end on a pretty colorful note. So I'm reading in the number 0, which is the numeric value for the color black in the CoCo. I'm reading in the text description of the color black, and then I'm reading in the ASCII code to generate a solid black block on the screen, and then rinse, lather, and repeat for all 8 colors. So color 1 is green, that's its ASCII block. Color 2 is yellow, that's its ASCII block. Blue, etc. So I'm reading these in, and unfortunately, because of the mixed nature of the data, I'm dealing with a numeric variable, a string variable, and another numeric variable. I could not make it a 3-dimensional array. And unfortunately, with these 3-dimensional arrays, I'm having a hard time thinking of a context when you can take this information abstractly and just pull out one piece of subset from it. I can't see how you can really use this data unless you're using it as a block, and you can't just pull one piece out of here unless you almost have to assign a new single variable to equal subset y of z of x, and it's just crazy. So I'm trying to think through this formulaically and algebraically and numerically, and I can't think of any good examples of how this is really practical for most things you would do in BASIC. This almost sounds like these are scientific spreadsheety type things. I just don't know. But anyway, so I just said, hey, this chapter is dealing with data. This chapter is dealing with reading in data and then displaying the result of the data. Let's make it pretty. So mine's dealing with the numbers, the names, and the actual looks of the 9 colors that the CoCo can produce on a text screen. And so we'll go ahead and we'll run it, and we'll see what Willis is talking about here. RUN, and then boom. So the colors of the rainbow, or at least the CoCo. So we've got black, green, yellow, blue, red, buff, cyan, magenta, and orange. And then it says, hey, what's this got to do with analyzing? Anyways, because I really haven't analyzed anything, right? I haven't asked you a question of which candidate in which precinct of which group do you want me to give you one arbitrary number for. That is analytical. I get it. But how often am I going to do that? I don't know. But if you want to read in a bunch of data and then be able to drill somebody to ask them a bunch of questions to show them one single piece of that data, you can. And it's in this chapter right here. And I just showed it to you. And my head still hurts. Hopefully your head doesn't hurt. Hopefully these pretty colors here at the end of the rainbow and at the end of the chapter have made up for all of the pain that has been happening inside my brain from trying to even explain this thing to you. But I am not trying to rush through this. I'm not trying to be sarcastic or condescending. This is literally the best I can do. And if it's not good enough, I'm freaking sorry. But I did it. I finished a chapter. I finished this video. I'm going to end the recording now, and I'm going to upload this crap. And hopefully somebody will enjoy this because I need a beer. All right, guys. CoCo forever. #commitment CoCo. May your world be a CoCo world, and may all your CoCo dreams come true. Bye-bye, everybody.